So,
oh my God, no, never mind.
You better. No, you just don't have to. So, okay, so we are gonna, we have wrapped up three-dimensional, and we're gonna go into the next unit, which is on circles. This is the second to last unit that we'll be doing. So chapter 11 and chapter 12 are the last units that we'll be doing in quarter 4. All right, so what we're starting to talk about are things that intersect circles. So lines and segments that intersect circles. So before we talk about these, what is the difference between a line and a segment? Bianca?
A line goes on forever.
A line goes on forever. And Miguel, a segment? Okay. Well, if a line goes on forever, nobody needs a segment.
Doesn't it have an endpoint?
Has endpoints. Yeah, a segment has endpoints. So a line would go on forever, a segment would have endpoints. So which color up there on the board is a line?
Blue.
Blue. The blue one is a line. Which one is a segment?
Red.
Red? Okay, which other one is a line?
Green.
Green. They're both lines because they have arrows in the end, whereas the red one is a segment because it has endpoints. So a chord is a segment whose endpoints lie on the circle. So a chord is a segment, which means it doesn't go forever, and it lies on the circle. Endpoints lie on the circle. So right here, we'd have an endpoint at A, and we'd have an endpoint at B. So that's called a chord. And it can go anywhere, all right? It can go through the middle. It could go right here. This could be a really small chord. It could go right here. That would be a larger chord. But those are all chords. They are segments that go from one endpoint on one end of the circle to the other on the other end. A secant is a line that intersects the circle at 2 points. So a secant will go through the circle and will touch it twice, but it doesn't end. So basically a secant is like a chord that just goes on forever. What does it look like is the difference between a secant and a tangent? Because a tangent is also a line, but what's the difference?
They have a point of tangency.
They have a point of tangency, that's true.
Secant goes through.
Secant goes through the circle. What does a tangent do?
Out.
It's outside of the circle. It just like brushes against it at one spot, and that spot is called the what? Point of tangency. So the tangent only touches a circle at exactly 1 point, and that point is called the point of tangency. Okay, so a tangent is outside of the circle. Chords and secants are in it, but a chord ends and a secant goes forever. All right, so in this circle, we have 3 lines or segments, and we want to identify them. So what are the lines and segments here? EF. Is EF a line or a segment? A line. Okay, so then that means, is it a secant, a chord, or a tangent? This is a secant. All right, it's a secant. How come it's not a tangent? It goes through the circle. So a secant goes through the circle. Okay, what's another one?
Line C.
Line C. There's no line C.
Yes.
Oh, line L.
Line L. Why can't we just call it line C?
Because C is an endpoint.
C is just a point on the line. We would need it to be, we would need 2 letters there. All right, so line L is a what?
Tangent.
Tangent. Which makes point C the what?
The point of tangency.
Point of tangency. All right, and then last but not least, what's our last thing? BC, which is a chord because it's a segment. And since it goes through the center, more specifically, that chord is actually the what? Diameter. Does it have to be a diameter to be a chord? No. Okay, this one just happens to be. Because it goes right through the middle. What is AC? If I asked you what AC was, what would you tell me?
The radius.
AC is a radius. Good. What is BA?
Radius.
Also a radius. What about AB?
A radius.
A radius? Okay, all of those are then what?
Diameter.
No, altogether it would be a diameter, but they have to be what to each other?
Equal.
Equal to each other, congruent to each other. So the radii are all the same, all right? So from A to anywhere, like if I connected AF, that would also be a what? Radius. Okay, so that would also be a radius because it goes from the center to the outside and it touches on the outside. congruent if and only if they have congruent radii. So if AC and BD are equal, then these circles must also be congruent. Okay, so if the circle has the same radius as another circle, then those circles are congruent. Concentric circles are coplanar. What does that mean? They're on the same plane, so they have to be on the same like flat surface. They're coplanar circles with the same center. So essentially, concentric circles, how would you describe this picture if you were describing it? In like your own words. A circle that is inside another circle. So a concentric circle is basically a circle inside of another circle. Could concentric circles be congruent?
No. Yes.
They maybe could, but then where would they have to be, right?
In the center.
They would have to share a center, which means that those two circles would be like if this one were here, the other one would have to be where? Right on top of it. Okay? So you would not see that a lot. So concentric circles, essentially, if you think about it, is just one circle inside another.
So they have to share a circumference.
Yes, they would share a circumference. They would also, like if they were right on top of each other. Here, would these share a circumference? No, because the blue radius would have to be what? Smaller than the red radius. Because if they have the same center, that means to get to the blue is shorter than to get to the red. Two coplanar circles that intersect at exactly one point are called tangent circles. So we can either have internally tangent circles or externally tangent circles. What's internally versus externally? Internal, one's inside the other. How come those are not concentric?
Because they're not in this, they don't share center.
They don't have the same center. Good. All right, so those don't have the same center. And then externally tangent circles, where do they touch? Just one point on the outside. Yep, so those they don't share any like common in space. They're just next to each other. Okay, so are these concentric circles right here?
No.
No. Are they tangent?
Yes.
Internally or externally? Internally. Okay, so A and B are internally tangent. What is the radius of circle A? Which one's bigger? A is bigger. What's the radius of A?
5.
4. 5. 4.
4.
The radius of A is 4. What's the radius of B?
2.
2. Where would the point of tangency be? 4, 0. We're on a coordinate plane. Is it 4, 0?
Yeah.
0, 4.
0, 4. 0, 4, yeah. Oh, wait.
No.
Yes.
4,
0. Yeah. 4, 0.
Still don't agree.
4, 0.
Because 4, 0 would be over here.
Negative 0. And then 0.
3, 0.
3, 0. Okay. All right, this is 3. This is the axis, so 1, 2, 3. So this point is 3, 0. So that's where the point of tangency is. And then a tangent line. Yeah. Okay, a tangent line. What do you think a tangent line is?
A line that is tangent.
A line that.
That is the same plane as a circle.
Okay, it's definitely on the same plane. What does it go through? The point of tangency. And then does it go through the circle, or is it?
Next to the circle.
It's like perpendicular to the circle. Okay? So the equation of the tangent line then, an equation of a line is either x equals or y equals. This is what kind of line, vertical or horizontal? Vertical, which means it is x equals, because it's kind of the opposite of what you would think. So it's x equals what?
3.
3.
That's it?
Yep, that's it. So the equation of a tangent line is either going to be x equals something or y equals something. If it were horizontal, it would be y equals. If it were this, it would be y equals -5. So you just figure out where it goes through. Because at every point on this line, this would be 3, 3. This would be 3, 2. What is x always? 3, which is why the equation is x equals 3. Because the equation of that line is always x equals 3, no matter what the y is. All right, so a tangent line goes through the point of tangency, and it is like perpendicular to essentially the circle, but perpendicular to the radii of the circle. Okay, go try these 7 at your 8 at your boards. For A, B, C, D, and E, you're just telling what it would be. So secant, tangent. All right, so the only thing, really quickly, point of tangency is where those two circles touch each other. It's not where the circle touches the axis. It's not down here. It's right here. So that would be 4, 2. And then since this is a vertical line, the equation is x equals 4. If it were horizontal, what would it be? Y equals 2 if it were a horizontal line. Good.
But it wouldn't be a point of tangency.
But then on this one, there would not be a horizontal line. I just mean if the circles were on top of each other and it was a horizontal tangent line, then it would be a y equals. Okay, so when there's two circles that have a common tangent, that's a line that is tangent to both of them. So the red lines here are tangent to both circle A and B. The blue lines are also tangent to A and B. What's the difference between the red lines and the blue lines?
The red lines never. Well,
They would touch, but where?
Further on.
Like further on down here, okay.
They're not perpendicular.
They would be to some radius, but just visually, what's the difference between the red and the blue?
One's cross.
Yeah, the red ones are on the outside of the circles. The blue ones go where? They cross in between. They make a what? An X. So those are called common internal tangents because they make an X. All right, and common external tangents are on the outside of the circles because they don't ever, like, they do not cross in the middle. Okay, so P and Q are internal tangents, they'll make an X. All right, now, if a line is tangent to a circle, then it is perpendicular to the radius that goes through the point of tangency. So again, this line is perpendicular to the radius that goes from B, which is the point of tangency where it touches, down to the center of the circle, which means this angle right here is how many degrees? 90 degrees. Okay, so this is 90 degrees, which means this is also 90 degrees. The same works backwards. If I tell you that M is perpendicular to DC, then you can tell me that M is a tangent line. Okay, so the same thing works backwards and forwards. Tangent lines have to be perpendicular, and if a line is perpendicular, then it means it's a tangent line. All right, you don't really need to know these, you just need to be able to know that this angle is what? 90. That's going to be the useful part of this, because I can then say, okay, what if I'm looking for this piece, what shape does this make? A triangle, so I'm going to use that in the future. All right, now, if two segments are tangent to a circle from the same external point, so if two segments meet at the same point outside of the circle, these two segments have to be congruent. So if they start, like if I started down here at C, and I went, and this was tangent here, and this was tangent here, then I could say that this line is congruent to this line. Right? If they meet at the same point, those two lines are congruent to each other. Sorry, two line segments. So how would we use that here to figure out DF? You can equal them to each other because you know that these two line segments have to be congruent since they start at D outside the circle and they both are what to the circle? These are both what? Tangents. They're both tangents, they meet at one point, and then we can say that 5y minus 28 must equal 3y. So how would I solve this?
Minus 5y.
Minus 5y, which gives you negative 28 equals,
-2.
and then how would I finish?
Divide by -2. Y equals 14.
And if the question says find DF, what would you do?
Plug back in.
Plug it back in, so 3 times 14, which would give me
4.
so DF equals 42. That means DE also equals 42. So could you have plugged it into the other one?
Yes.
Yes? Why would I always choose this one?
Smaller.
It's smaller, it's easier, shorter, less work to do, right? So since they're the same, you can kind of choose which one you want to plug it into. It doesn't really matter, they have to be equal. All right, at your boards, find GH in both figures. Do not just find X. When you go up there, it's really hard to see on your slides, but this is a plus sign, this is a plus sign, and this is a minus sign. Go.
Can I go right